superpositions at first case source plus an equal sink. Each of the three elementary flow patterns that introduced before, which are constant velocity, constant one direction, source and sink, and rotational line, irrotational vortex. Is an incompressible irrotational flow and therefore satisfy both plane rotational flow equations. So we have incompressible irrotational would plane rotational flow satisfy potential flow with the equations, continuity equations, and also in the form of potential velocity we have these relations. Since these are linear partial differential equations and any summation of such basic solution is also a solution for problems, some of these composite solutions are quite interesting and useful. For example, consider a source. As previous, we have for source and sinks, we have parameter m for source and sink. We have m, which was 2 pi b. B is the the length of the pipe manifold, for example. And for source we have m greater than 0, and for sink m smaller than 0. For consider a source and sink as this picture at two locations. For example, suppose that source is at the x and y minus a and 0, and for sink we have for a source at the point minus a and 0, and for sink as shown the flow will goes from source to the equal sink. So we have two relation for the source and sink separately. For source we have relation m theta from previous, and theta is equals to tangent inverse the, for example, plus A, and for sink we have the streamline function. So we can write the total sink, the streamline of this flow from sink and to source to sink, which is source plus sink, which can be equals to the equality of source and sink is determined with the strength of the source or sink M. And for the potential flow we had this relation phi source M ln R. R is for source y square plus M on and also with this derivation we have calculated for sink minus M ln R y square x minus a square for sink. Now we can obtain the phi for this flow type, a superposition of our previous elementary flow pattern. M ln a square. This is the relation for the potential velocity of a superposition case of a sink plus a source equals sink and source superposition. Sink minus M and as shown in the picture previews, the lines are seen to be two families of orthogonal seekers with the streamlines passing through the source and sink and the potential lines encircling them. They are harmonic Laplacian functions that are exactly analogous in electromagnetic theory to electric current and electric potential patterns of a magnet with the poles of electric magnet, similarity to the